Hi everyone and welcome to the Zoyam Academy channel. This is the start of series of videos on model reference adaptive control for first order systems. And this video series assume you already have some basic background on what adaptive control is. If you would like a specific refresher on adaptive control, just let us know in the comment section so we can take that in account when coming up with videos in the future. Okay, so we will be, like I mentioned earlier, we will be breaking this video series into 4 different parts, right? And the first part is going to mostly focus on the introduction to what model reference adaptive control is, also named as MRAC. And that's kind of that's the name I will be mostly using going forward. And the second part is going to be on the derivation of adaptive control for first order systems. The third and fourth part are mostly going to be on solving an example for a first order system and then coding that in MATLAB. And so those are the 4 different video series are going to be focused on that. And so these are the different references that we've used. And so at the end of this video series for the MRAC, you will be able to understand what is MRAC, and you will also be able to derive the MRAC control law and adaptive law equations for a first order system. And lastly, you should be able to implement MRAC using MATLAB. So I hope by the end of this different video series, you have a good understanding on what MRAC is, how to derive it, and how to actually implement it. So, introduction to MRAC. All right, so what is MRAC? Essentially, MRAC is a fully model-based adaptive controller. And it can be viewed as also as an online parameter adaptation or online parameter estimation, sorry. And more on that later, but it's a very powerful method that can do a lot of different things. Like you can see there's an indirect adaptive. It can do indirect adaptive control, and you can also do like a direct adaptive control. Now, the main difference between that is in the direct adaptive control, we are estimating the control parameters without actually estimating the plan parameters. So in some sense, we are assuming that the plan parameters are known and constant in some sense, while in the indirect adaptive control method, we are mostly like what we do is we computing the control parameters by also estimating the plan parameters. And so we therefore rely on convergence of the estimated parameters to their true values. And essentially, let me get my pointer here. So essentially, what MRAC considers is it considers 2 key things, right? It considers a reference model and it considers a controlled system, which is a plant, right? And you can consider your plant as basically be your actual system, and you have a reference model that you want your actual plan to track in some sense. And so the idea is we are trying to make the output or the state, the output from the reference model be the same as the plan. So we're trying to bring those 2 guys, make these 2 guys equal. So essentially we have we have 0. So if the error comes out to be 0, then we don't need any adaptation, right? That's basically what it's saying. But if we have some form of error, then we want to be able to change the adaptation. We use the adaptation law to vary the controller parameters, right? And more, you will get a little bit more on the understanding on what I mean by control parameters or variable parameters and all of that in mostly part 2 of the video series. But for now, just understand that the idea is to make ym be equal to y, right? So we have an error which is going to be y minus ym. And we're going to also look for the aerodynamics in order to be able to determine what the adaptation law is. And one way we do that is using the Lyapunov theorem, which we're going to Lyapunov stability theorems, which we will be going over. Okay, so the three key steps that we have to take into account when designing model reference adaptive controllers is to choose a control law. And basically the control law will contain the variable parameters. The next step is to get the adaptation law for adjusting those variable parameters. And like I mentioned, if the error is 0, then you don't need to worry about the adaptation law. But when you have an error, then the adaptation law needs to be adjusting the variable parameters. And the last one, which is mostly for the indirect adaptive control, is to analyze convergence properties of the resulting control system. And like I said, I didn't mention this earlier, but this video series, I'm mostly going to be focused on the direct adaptive control method. We will not be focusing on the indirect. But in the future videos, we'll be coming up with simple examples for the indirect adaptive control, just as we are for the direct adaptive control. So that is all for now for part 1 of this video series. Please don't forget to subscribe to our channel so you can continue to get more of these great videos. Thanks for watching. See you guys next time. Thank you.